Good day, we are the members of Group B. I am Noel Ali.
I am Andrew Sinan.
I am Timothy Slama.
We have been hired by a large engineering company to design a citrus fruit juicer.
The citrus juicer is designed for mass production and distribution for a wholesale market as a household appliance.
Each of us have roles in the design process of this citrus juicer.
My roles were innovation, report writing, critical thinking, and performing analytical calculations.
My roles were design processes, performing analytical calculations, attention to detail, proficiency in SolidWorks.
My roles were organizational skills, report writing, proficiency in SolidWorks, and research and competence in design software.
And my roles were time management, creativity, report writing, and proficiency in SolidWorks.
We hope you enjoyed our presentation.
The group members were Noel Ali, Rishi Jairam, Andrew Sinat, and Himwati Sudama. Our team has been hired by a large engineering company to design a citrus juicer for mass production and distribution to a wholesale market as a household appliance. The following slide contains background information found about citrus juice while doing research. Citrus fruit contains necessary components which is vital for our well-being. Some of these include potassium, vitamin B, and in particular vitamin C, which is highly concentrated in the juice. It is a natural source of antioxidants and vitamins, which is needed for disease-free lifestyle, as well as certain aspects of the body are aided by consuming the juice. Techniques have also been developed to extend the shelf life of the juice. Citrus juice not only provide health benefits, but a lot contribute to the economy through employment. Our problem statement is a household citrus juicer that is easy to mass produce and distribute is required by an engineering company. To solve this problem, we need to design a citrus juicer that is easy to manufacture, best suited for distribution, user-friendly, and safe to use. The project aim is to design a citrus juicer for a large engineering company for mass production and distribution to a wholesale market as a household appliance. While doing the literature review, we found citrus juice contains materials needed for the body to remain healthy and function properly. Citrus juice is very popular around the world and is always on high demand, resulting in a market for the product. Many processes are used to extract the citrus juice. However, the process used is highly considered, since the quality of the juice is affected according to the method and system used. The quality of the juice can be enhanced through different processes, which can be very profitable. The economy highly benefits from the citrus juice industry, since a profit is brought in and a source of employment is made.
To progress with the project, patterns were observed and considered to simply just initiate the curiosity and thinking mentality needed for this assignment. For instance, for pattern 1, the fruit juice extractor is a mechanical device used to separate the fruit juice from the fruit and simply just fill the juice in a container. And how this works is by the cut fruit is mounted onto a platform and the user turns the mechanism, allowing the fruit to rotate, causing the juice to simply be extracted. This pattern was quite useful. The principle of the arm together with the mounting mechanism to hold the fruit in place were used in our conceptual designs. Now for pattern 2, the fruit is compressed and forced through an orifice to obtain the juice via a press operation. And this pressing technique was also used in the conceptual designs together with similar ideas of the perforated disc. Further, for pattern 3, the citrus reamer and press uses both mechanical and electrical power. The cut fruit comes in contact with the reamer via an actuating arm, and the force is applied allowing the reamer to spin via an electric motor. And this is based on the pressure applied to the shaft via the actuator arm. This then to juice the fruit, and the juice then goes into a collector and further into a container. And the idea of this external container is used in our conceptual designs. Moreover, for pattern 4, an automatic juicer turns and pushes an upward facing cone into a fruit and releases the juice. This system consists of gears, motors and shafts, and uses rotary motion to withdraw the juice and catches it into a bowl. In this, the idea of hinges to secure the lid to the base were used in concepts, together with the non-rotating strainer around the juicer cone.
Design conditions. Client and user requirements. The client requirements, which is the engineering company requirements, include the device should be cheap to manufacture, easy to manufacture, safe to use, durable, and a suitable size for storage and distribution. On the other hand, the user requirements, which is the customer requirements, include the device should be safe to use, user-friendly, aesthetic, compact size, easy to clean, and hygienic. Design specification. The design specifications are as follows. The device should operate using a household voltage of 110 volts, a compact size of 10 by 10 by 15 inches, able to hold a capacity between 400 milliliters to 1 liter, weigh 6 to 8 pounds, and have a durability of 3 to 5 years. Key attributes. The key attributes that were considered when designing the device are as follows. Cost of manufacture, user-friendly, weight, size, aesthetics, ease of manufacture, and safety. Functional decomposition. Metrics. The key attributes will be analyzed using a scale from 1 to 3, with 1 representing the worst and 3 representing the best. For example, cost of manufacture will have expensive under 1 and cheap under 3, indicating that cheap is more important than expensive. Pairwise comparison chart. A pairwise comparison chart was used to determine the weight percentage of each key attribute to determine the most important to least important for the design. The key attributes rated from most important to least important are safety being the most important, followed by user-friendly, cost of manufacture, ease of manufacture, aesthetics, size, and weight being the least important. Black box. The black box represents the input, function, and output of the device. Citrus fruit and energy source goes into the citrus fruit juicer and results in citrus juice, sound, heat, and vibration, and citrus waste such as pulp, seeds, and skin. Transparent box. The process is further broken down in more detail. The citrus fruit is cut in half, inserted, and secured in the device. The device then juices the fruit and separates the juice from the waste. The juice is further collected, and the amount of juice collected is regulated. Functional decomposition chart. The citrus fruit is cut in half and inserted into the juicer. Mechanical and electrical energy are used to power the device to juice the fruit. The juice and waste material are then separated. The juice is then collected and measured. The final products are the citrus juice and waste. Function means tree. A function means tree is a technique for functional decomposition and concept generation. At the top is the main function. For example, the citrus juicer. The juicer can operate either mechanically or electrically. These are known as means. This is followed by peel the fruit or don't peel the fruit, which are called sub-functions. The fruit can be peeled using a fruit peeler, which is an example of a sub-mean. Morphological chart. This is used to show different options for a specific action. For example, the options for energy sources are electrical or mechanical.
Concept generation. In the following slides, labeled isometric, front, side, and sectional views are shown of each concept done on SolidWorks. Concept A was designed as an electric device where the citrus fruit has to be peeled and cut into pieces before it enters the mouth of the device. There, the press plunger derived from pattern 2 can then be used to ensure the fruit reaches the shaft. When turned on, this shaft is rotated via a motor and gears. The shaft consists of helical threads which aids the fruit to go in the direction of the perforated disc to be compressed. The juice is extracted and then flows through the perforated nozzle and into a container or cup placed by the user. The perforated nozzle is similar to the orifice tube from pattern 2. Concept B is a manually operated design which draws inspiration from patterns 1 and 4. The fruit is cut into halves and mounted onto a juicing cone in the jug and secured in place when the cover, consisting of a hemispherical cup with spikes, is placed over the jug. A spring below the juicing cone ensures that it is continuously pressed into the fruit. A crank arm is connected to the cup and when rotated, it spins the fruit into the juicing cone. This results in the juice being extracted and the seeds and pulp are filtered separately via 2 removable filters, similar to that of pattern 3. The filtered juice flows into the jug and thus can be utilized by the user when the juicing components are removed. The design of Concept C is quite like that of Concept B and hence patterns 1, 3 and 4, the main difference being that this one is electric. The fruit is cut into halves and secured onto the juicing cone. The lid is then attached and the switch is turned on for the motors and gear system to turn the juicing cone on the shaft. However, there is no mechanism in this design to prevent the fruit from rotating with the juicing cone. The juice is then extracted and filtered inside the funnel and then travels through a sprout into a removable container. Pew chart selection matrix. After concepts were generated, each was given raw scores of 1 to 3, with 3 being the best, for their compliance with each key attribute. The total weighted scores were calculated and the results are shown in the pew chart. Concept A had the lowest total weighted score because it was determined that it was expensive and difficult to manufacture due to complex parts. Concept B had overall good raw scores as it was the simplest design, that is, with no electrical parts. However, Concept C had the highest total weighted score since it was user-friendly, safe to use and aesthetic. Using these results, our final concept was based mostly on Concept C, but we used components from A and B to improve it. In our final concept, we combined components from all the concepts, mainly C. The fruit is cut in halves and mounted onto the juicing cone, and like Concept A, a press plunger with spikes would be used. This mechanism is upgraded as a sensor would be put in place in which the more force used to press the fruit, the faster the motor would spin. After the fruit is juiced, it is filtered through 2 removable filters, one for seeds and one for pulp, similar to Concept B. However, these are designed to slide in to either sides of the shaft through slots. As the juice flows through the filters, it then enters a funnel tube, where the design aids the juice to leave the system via a sprout at the bottom of the tube, and the juice is collected into a container placed by the user. This design was chosen for our final concept as it best suits the key attributes chosen and meets the requirements previously stated. References. The following is a list of references of patents, peer-reviewed journals, and websites used to complete this presentation. Thank you for viewing our presentation.